Hello viewers, welcome back. Today we'll be talking on a topic which is exponential decay. What is exponential decay? Exponential decay states that the time rate of change of mass is directly proportional to its initial mass. The time rate of change of mass is directly proportional to its initial mass. If you have the time rate of change of mass, dm all over dt varies directly proportional to its initial mass. Let's say m as initial mass. So it means that we have to change this vary sign. We have dm all over dt is equal to what? Km, where k is our constant of proportionality. So this simply means dm all over dt is equal to minus km. The reason we have a negative constant is means that what? There is a reduction in the mass. So because exponential decay, it means the decrease of things. We have a constant of what? We have a negative constant of proportionality. So in this case, we now have dm all over dt is equal to minus km. So we have to solve this so that we can get a subject to this. Our mass will be a subject to all this. So how can we now solve this? So this is a what? We can use variable separable to solve this. So it will now have dm is equal to minus km dt. I multiply this by this. So I can now use variable separable. Variable separable means that what? We separate the variable. This is m. We have to take our m to here. Our k will remain with dt because it's a constant. There's no value for it. It should remain with this. Our m will go here. It means that what? We have separate m to go to here, and our k is always remain with dt. So what I'm going to do? We have to use variable separable. So that's what I said, using variable separable. Using variable separable. So we now have dm all over m minus km dt all over m. So this will be able to cancel. Now I can simply write this like this. I can simply write this like this. 1 over m dm minus k dt. 1 times dm, we get this. So I can write this like this. Minus k dt. Since we have separated the variable, our next step is to integrate the side. We have to put our integral sign. So if you integrate 1 minus m, what are you going to get with respect to dm? If you integrate minus kt with respect to dt, what are we going to get? So let's apply our integral sign. Integrate both sides. One all over m dm minus k dt. So if we integrate 1 all over m, what are we going to get? So we are going to get ln m. This is a standard integral or definite integral. This is a standard integral or indefinite integral. We cannot call this one a definite integral because there is no boundary. We don't have a boundary point. So in this case, what are we going to do? We are given that we have 1 over s respect to s. We want to integrate this. This is our denominator. Let u is equal to x. If we differentiate this with respect to s, what are we going to get? We have du over ds, which is 1. If we say du over ds is 1, let's make ds as a subject. We have ds is equal to du. So in this case, let's take our 1 over s ds integral of this. 1 over s ds. This implies that integral of 1 over, what is our x? Our x is u du. So 1 over u du, what are we going to get? Remember in our differentiation, if we are integrating 1 over s, we get ln s. If we differentiate 1 over s in integration, we are going to get what? So if you have 1 over s d over ds with respect to s, we get what? Ln s. So it means if you have 1 over u, it means we are going to have ln s. So it means if we differentiate if we take 1 over s, we are going to get what? Ln s. It means that's why we now have ln s plus c. So according to the law of integration, so that's why we have natural log of s plus c. Our s we must something like this. We have to take an absolute value of this, which means that what? All the value that will be here will be always, if it is negative, it will be positive. That's why we have absolute value. So if you now integrate 1 over m, we are going to get what? Ln m, according to the way I solve it here. So now I have ln m is equal to, if you integrate constant, it means our respect to that value is going to multiply that constant. T will multiply minus k, we get what? Minus kt plus the constant of the integration plus c. Since we have gotten this, so we want to get a subject of m. So what will be m will be the subject of this. We have to take the word. Taking the, we have ln and we want to cancel our ln. We have to take an exponential of both sides. We now have taken exponential of both sides. Taking exponential of both sides. We are going to have exponential ln m, exponential minus k, t, exponential c. So this will be able to cancel. We now have m is equal to exponential minus kt dot exponential c. According to law of indices. So m is equal to, if I have something like this is the same, this is this, I will take it at once. Our times will be what? Plus exponential minus kt plus c. M is equal to exponential minus kt plus c. So we can now have m is equal to c exponential minus kt. In this one, I can let my c be m naught, initial mass. Let c is equal to initial mass of exponential decay. I'm going to have m is equal to c exponential. Our c is mo. I'm going to have m naught exponential minus kt. And our mass is what? The reduction of what? Our mass is the what? Our mass of the exponential decay with respect to what? Of the time. So I'm going to have m of t is equal to m naught exponential minus kt. So this is the formula we are going to apply when finding anything of exponential decay. The reason we have a constant is that we have a reduction in mass. We have a constant. Our m naught is what? Initial mass. Initial mass, that is varies directly to the initial mass of this, and our m of t is what? Final mass. So in exponential decay, our m naught, our m of t is smaller than m naught. That is, our m naught, the size of m naught, initial mass, is bigger than the size of what? M of t, final mass. That is, our final mass is bigger than, our initial mass is bigger than final mass. So assuming we have our m of initial mass as 50, our m of t cannot be 50. So that is why we have a reduction in the mass. The reduction of the mass, that's why we have a negative at minus kt, because our m naught is much bigger than m of t. Our m of t is the final mass, our m naught is the initial mass, our k is the growth rate of the mass, and then our t is the what? Time. Our t is measured in seconds, is measured in hours, is measured in days, is measured in years. There's no specific measured unit for t. T can be measured in hours, days, week, years. So whenever we are given any question on exponential decay, we have to apply this formula to solve it. So watch my next video on how to use this to solve any question on exponential decay. Don't forget to subscribe, share, and comment.